May I request everyone to please stand up for the opening prayer. Yourself, please lead the prayer.
Classmates, let us Son, Holy Spirit, Amen. Our Father, who art in heaven, hallowed be your name.
So good afternoon, class.
Good afternoon, sir.
So how are you feeling this afternoon?
We're doing fine, sir.
Fine. Wonderful. Now before we start with our discussion, let us first make an agreement. Is everyone okay with that?
Yes, sir.
So everyone, please sit down. So we have here our agreements. So Jeff, please read our agreement number 1.
No using of cell phones while your class is still ongoing unless the teacher says so.
Now Hannah, please read our agreement number 2.
Raise your hand if you want to answer and answer in chorus.
Then Adi, please read our last agreement.
Always listen attentively.
Okay, do we all have an agreement?
Yes, sir.
Now before we start with our discussion, does anyone still remember our last topic? Yes, Jeff?
Our last topic, sir, is all about volume, density, and mass.
Very good. So, what is mass? Okay, Christelle?
Mass is the amount of water in your hand.
Okay, so what is volume? Yes, Christelle?
Volume refers to the amount space of the object.
Okay, very good. And lastly, what is density?
Sir.
Sheila? Yes?
Density is the compactness of an object.
Okay, very good. It seems like you learned a lot from our previous lesson.
Okay, so before we proceed to our discussion, let's first have an activity. So our activity is all about, or entitled, Base Making. So, Shala, can you please read our mechanics?
Mechanics. There is a power base like picture below, and I will place students randomly. Then the chosen one will answer the questions given to them. The students will choose their answer from the box and finish the list provided below, and put their answer in the flower provided.
Okay, so do we all agree to this?
Yes, sir.
Okay, so very good. This is the choices. Okay, so for number 1, Hannah, can you please read the question and try to answer?
An ability or tendency to float in water or air or some other fluid. Buoyancy.
Very good, Hannah. Okay. The second one, Roselle, can you please read and answer?
A body at rest in the void is occupied by a force pushing upward while it's a buoyant force, which is equal to the weight of the fluid that the body displays. Archimedes principle.
Very good, Roselle. Now, Sheila, can you please read and answer number 3?
Number 3. Simply defines the amount of space occupied by any three-dimensional fluid. I think the answer is volume, sir.
Okay, Shala, very good. The fourth one is, Crystal, can you please read?
It is the measurement of how tightly a material is packed together. I think it's density, sir.
Very good, Crystal. The fifth one, Adamarie, can you please read?
The force applied perpendicular to the surface of an object within the area over which that force is distributed. I think it's pressure, sir.
Very good, Ad. Now, last but not the least, Hannah, can you please read and try to answer number 6?
The measure of the amount of matter in a body. Mass.
Very good, Hannah. So now, before we proceed to our topic, I want you all first to read our objective. objectives. Can you all please read our objectives?
Yes, sir. Understand objectives. Understand and demonstrate Archimedes' principle. Investigate the effect of salt on water's density. Investigate the effect of salt on water's density.
Very good, everyone. And now, I introduce you to our topic, the buoyancy force and the Archimedes principle.
Alright, now we will have an activity in relation with our lesson. So I will group you into two groups. So this is for the group 1 and group 2. So each group will be given different activity. So let's start discovery. So is that clear?
Yes, ma'am.
Okay. So this is the activity of group 1. It is entitled, do I sink or do I float? So group 1 can read the instruction in mechanics.
Instruction. Illustrate the appearance of pregnant people in a glass of water. Mechanics. The group will have 2 glasses of water. They will put the coin and people ball in each glass of water. They try to observe what will happen and evaluate if it sink or float. Justify the difference between the 2 materials.
So group 1, you understand the flow of your activity?
Yes, ma'am.
Alright. So group 2, this is your activity entitled solve me. So can you read the instruction group 2?
Solve the buoyancy force of a given statement.
So the mechanics of your activity is I will be given a statement and you will be solved it. We find the buoyant force and give the findings to your solution. Okay. So can you read the situational statement group 2?
Sarah is conducting an experiment to determine the buoyancy force acting on a wooden block submerged in water. The wooden block has a volume of 0.05 cubic meters and density of 600 kilograms per cubic meter. The density of water is 1,000 kilograms per cubic meter. Calculate the buoyancy force acting on the wooden block.
Alright. So next, can you read also the formula and steps of your of the buoyant force?
Formula. FB equals P times G times V. Whereas FB is the buoyant force, P is the density of a liquid, G is the submerged volume, and V is the acceleration due to gravity.
Alright. Next, can you read the steps?
So steps in solving buoyancy force. First step. Identify the given information. Evaluate the formula. Determine the density of fluid. Determine the volume of displaced fluid. Apply the acceleration due to gravity, which is 9.8 meters per second square. And calculate the buoyancy force by substituting the equation formula.
Alright. So group 2, do you understand the flow of your activity?
Yes, ma'am.
Okay. So both of you will be given 3 minutes
because there is no way that the coins will be much denser than the water. So, yeah.
Alright. Thank you, Group 1. So let's give Group 1 a, what do you want? Correct Crisantino or imagination club? Imagination club. Alright, so please stand up. Let's give Group 1 imagination club. 1, 2, 3. 1, 2, 3. Very good, very good. Alright, so let's give Group 1 imagination club. 1, 2, 3. 1, 2, 3. Very good, very good, very good. Alright, now let's have the second group, of course. So let's have the second group.
So we are the group 2, so we are tasked to solve the problem or the statement given in us in the PowerPoint presentation. So the given formula is that buoyant force is equals to the density times the grams and acceleration of the object. So in the given statement, these are the givens. So the density is the 1,000 kilograms per cubic meter times the 0.05 cubic meter times the 9.8 meter per second squared. So our answer is the buoyant force is 490 newtons. Since the buoyant force is equal to the weight of the space fluid to the buoyant, so the buoyant force acting on the wooden block submerged in water is 490 newtons. So it means that that's why the wooden block floats, because there is a 490 newtons that exerts an upward force. That's why the wooden block floats. Now,
Alright, so this is a very excellent answer. So thank you, Group 2. So let's give Group 2 a correct Crisantino class since they are all correct. So now let's stand up everyone. 1, 2, 3. 1, 2, 3. Correct. So righty. Please. 1, 2, 3. 1, 2, 3. Correct. Alright. Please settle down. So based on the answers, do you have any questions or clarifications regarding to the report or the activity? None. Alright, so again, the answer of Group 1 are all correct. I see that your answer also are all correct. So now let's proceed.
so now that you have already know our topic for today, it is all about buoyancy force and Archimedes principle. So now, are you ready to have an experiment time? Yes, ma'am. I can hear you, class. Yes, ma'am. All right. So now our experiment is entitled, "Would you dive in the law's buoyant test or keep afloat in the wake of romance?" So I have here prepared the materials. I can let you handle these experiments because it is limited. The materials is only limited. That's why I am your teacher. I will do the experiment. Just please observe properly and take some important observations that you will observe. Okay? So the materials I have prepared are the beakers, the 1,000 beakers, 1,000 beakers, 250, it's 250 ml beakers, the steering rod, the spatula, egg, and salt. So are you familiar with this laboratory materials class?
Yes,
So what do you call these materials again? How about this? How about this? How about that? Egg! Okay.
3 eggs.
Of course.
Flowers and
So let's arrange to avoid some. Do you have any papers or markers? Can I borrow some? Because you will. Because you will. Crystal, can you please write A, B, C, D? Okay, so since I will prepare some amounts, you can help if you want, class. Okay, can you please tell me if it's the liver is was
Second,
Tell me.
relative zero.
Okay.
I think that the egg of C.
Okay. Here, I have here raw eggs, 3 raw eggs. We will use raw eggs. And also a 100 grams of salt. And these, okay, take notes. So now, we will put this egg in this hot water and observe what will happen. What did you observe? That's the okay. So in our bigger plate, we added the 100 grams of salt in this 500 ml of hot water. So we will put another egg and observe what will happen. What did you observe, class? So what's the difference between the two beaker? Yes, please, Christelle, stand up. Thank you, Christelle. Very good. Well, in beaker C, we also added 100 grams of salt, and we will also add another egg, raw egg, in this, and observe what will happen. It's still close, right? But in this time, we will add another hot water on top of it. Observe what will happen, class, okay? Slowly put or add the hot water. What did you observe, class? The middle. Yes. But let's still add some hot water. Oh, the egg is wow. Another water. What principle is that? So now that you're curious, I will tell you what principle is this. So the bigger A, this is the Archimedes principle. The bigger B represents the buoyancy force, while bigger C represents something. But it's a secret for now, and I'll tell you later on. So what's the Archimedes principle again? Anyone? Yes, Christelle?
So, Archimedes principle is where objects are at rest in a fluid is often applied by force pushing forward and upward rather than pull the buoyant force.
Okay, but can you please remain stand and relate your answer on this experiment? So another example of buoyancy force is when you're swimming. You feel your body is lightened, and it's the same in the boat is floating. While here in the bigger sea, in real life situations, it is the same with the Atlantic Ocean and the Pacific Ocean. As you can see, the Atlantic Ocean and the Pacific Ocean cannot be combined together. There's capacities in between them because one fluid is less dense than the other. So now, let's thank you, class. So now, did you learn something, class? Yes, ma'am. Okay. Alright. Did everyone have fun while learning? Yes, ma'am. That's great. Now at this juncture, let us test what you have learned. Kindly get one sheet of paper, write your name and number your paper from 1 up to 10 and answer the following questions. Read and answer silently as to not disturb the others. Choose and write your answer to the best letter that you strongly believe is the right answer. And if you have any question, ask me, not your seatmate. Are we clear? Yes, ma'am. All right. Good luck. You may start now. Done? Next one. Wait. Was very easy, right? Mom, it's hard. Is everyone done? Yes, ma'am. Next. The last one. Good job. Now exchange your paper with your seatmate. Now let's check your paper. Number 1 is B. Number 2 is A. 3, 4 is B. 5 is A. 6 is C. 7 is A. 8 is B. 9 and 10 is A. Pass your paper in front. You still got perfect, Mom. Very good.
Thank you.
Is there